Thank you very much. I crammed as many adverbs and adjectives into the title of this talk as I could to draw you here, so thank you for coming. So I recently left Mozilla to start at a startup called Votizen. We're going to fix American democracy, and that should be pretty simple, right? But before that, I was at Mozilla, where I did lots of work on various web apps. Had a lot of fun, wrote a tremendous amount of code, and I wanted that code to work. So we wrote a lot of tests as well. This session is all about how to keep large test suites manageable over time. And by manageable, I mean I want them to be fast to run. I want them to be maintainable, so that as they grow, you don't go crazier and crazier. And I want them to be informative when they're running and after they're done running. So we're going to start today with a fast, and then we're going to move on to keeping from going crazy, and then finally we're going to talk about some tools for improving test output quality and helping them hold your hand as you debug. So Mozilla is pretty serious about quality control, and you can see it in the rack space. This is a picture of Mozilla's mobile test cluster. It's where we test the cell and the tablet versions of Firefox. And they're basically a bunch of disembodied cell phone brains with antennas sticking out of them, and we have a special reinforced door to keep zombies out. It's kind of like being in a room with a noisy Christmas tree that's trying to irradiate you all the time. But my favorite part, bar none, is the lovingly organized power bricks. We also have a whole stack of Mac Minis, and we use these to test the desktop versions of Firefox. Aside from being low power and compact, and you can buy little rack units for them, jam them all together, they run all three major OSs really well, and so we can just switch back and forth and re-provision as our load changes. But my department is web development, and we have, as you might imagine, several sites that get quite a bit of traffic. We have the support.mozilla.org site, which gets about 1 billion requests a month. Some of them are cached. Then we have the Snippets site, which gets 5 billion hits a month. And Snippets is, if you ever looked at the default Firefox homepage, it has a little Google search, and then right below that there's some kind of little advertisement about, oh, isn't Firefox great? Or here's a soap thing, and that's served out the Snippets site. And then biggest of all, we have the add-ons site. And 30 billion hits a month, that just counts the update service. So that's when Firefox says, hey, I'm version 8.1, do you have an 8.2 for me? Or I've got add-on version 4, do you have a 5? Do I hear 6? So with so many people affected by these things and all this traffic, we're really fairly careful about what we put into the code. We do kind of buddy system code reviews. If I want to put something into the tree, I'll push it up as a GitHub pull request, and then one of my buddies on the team has to say, yeah, looks sane to me, or have you thought about this corner case, that corner case, and then we push it in. And of course, we back all that with a ton of automated testing. Here is our Jenkins readout for our build farm. As you can see, there are several projects here, and you may even notice a couple of duplicates. Take a look at these, for example. This is my project, sumo, support.mozilla.org, and you can see a job for master, which is where we do all our development. We have a build going for that. We have a branch for the JavaScript, separate job. We have a branch for our production run, so we're always testing what's actually on the servers, and then we have one for a staging server that we have some dedicated QA people who pound on that all day long. With all these duplicates and everything, it's a pretty busy build farm. We have 3 or 4 test slaves in there that just run all day, and it's pretty busy. But throwing iron at servers is not a terrifically interesting thing to do to me. What I care about is the humans who have to work with this stuff. How do we make it jam with our wetware? So let's talk about how the speed part is going to go. I'm going to tell you the story of my main project, Sumo, which has some of the cleanest code I've ever worked on in my life. It's tremendously, tremendously clean. It's all 80-column PEP compliant, PEP 257, PEP 8. It's ridiculous. It's the cleanest thing I've ever seen in my life. It's disgusting. But the tests are terrifically slow, terrifically slow. It's a Django project, but the tricks we show here are going to be applicable to anything, no matter what framework you're using. It's a general problem. We're going to look at some diagnostic tools. Where is the slow? We're going to look at some troubleshooting processes. What do we do about it? And we're going to see the specific remedies that pulled my project out of the muck. Then we're going to take a step back, and we're going to see how all this extrapolates to Python tests in general, no matter your framework. So, with no further ado, sumo. Support for support Mozilla org. It's a knowledge base, it's a threaded discussion forum, it's a Stack Overflow clone, you can put it on as a hat, whatever. We have about 1,200 tests when I left, get about 1 billion hits a month. I like to call it the smallest of our big sites. Now, when I joined up, the tests were sane enough. They were manageably sized, they had some global fixtures. Over time, they grew to be 20 minutes long on the build server and 5 minutes long on the laptop because it's not in contention for all that I/O. Now, 5 minutes locally might not sound like much, but you do start to feel it. For one thing, it wastes your time. Will sitting in the front here nodding like, yeah, I'm waiting right now, in fact. You twiddle your thumbs while the tests run, you waste your time. Now, a lot of us are kind of borderline ADD, so we switch contexts, right? We go do something else, and then we forget what we were doing, we dump our flow, we have to get back into it. That's even worse. I'd rather just wait. And the worst of all, and I used to see this on my team all the time, is people just don't run the tests, or more likely, they just don't run all of them. They say, I just changed this little thing in this one application. I'll just run the forums tests. I'll just run the wiki tests. And then you get a big surprise 20 minutes later when Jenkins says, hey, you broke the build over in this other little corner here. And you're like, oh, crap, now I've forgotten what I was doing. I moved on to this other feature, and the team's mad at you because you're holding them back from committing on master, and it's a big disaster. So this is a timeline we printed out that shows where we came from and then where we ended up. This is our goal. 6 minutes remote, 1 minute local. It's about all I can stand, Any more than that, and I get up on the desk chairs, and I'm sword fighting with Will and all this stuff. So what is our plan? Whenever I start optimizing, especially web app tests that have a database involved, I suspect I/O, because I/O is always the problem. This is a neat little thing I found last night. It's basically a picture of the memory hierarchy with one dot meaning a nanosecond of access time. So L1 cache, nanosecond. L2 cache, 5 times that. RAM, another 20 times that. Hard disk is not that big. This is not to scale. That actually goes down through the parking deck, down through the basement into the mantle. When I tried to put this, I was going to do this really cool thing in Keynote. I was going to have it zoom out into orbit, and you could see what the true scale was, but Keynote crashed 4 separate times when I was trying to do that. So that's how slow your hard disk is. So avoid the disk at all costs. I love, what would you call it? I love monitoring all the time. You got to monitor all the time. Get used to the baseline of what is normal for your machine. Get a copy of iStat menus is my favorite for the Mac, menu meters, whatever kind of monitor system you like, and just have a constant window into your disk and your network and your CPU activity so that you have a baseline in your brain and you can sort of see, well, maybe I should start looking at this on the hard drive, or maybe I should start looking at this in RAM use. But of course, before you do anything, you should always profile. Guessing is all well and good, but it's not actionable. You don't want any surprises. Now, the trouble is that the Python profiler doesn't tell you anything about I/O time at all. Everything is in terms of CPU. Oh, 5-second CPU, great, but it took 45 seconds. What were you doing? So we bust out the handy Unix time command. And this measures CPU and clock time of a command. You can look at the CPU percentage, and you can see that your tests are, by some simple subtraction, spending by far most of their time doing I/O. Time command's a great first whack at profiling. If it says CPU, fantastic, we have tools for that. You break out the Python profiler. If it says I/O, then you have to take some educated guesses. Now, if you're using a database of any kind, that's the first place you look. Is it SQL? Is it NoSQL? Whatever's flushing to disk, or whatever is listening over a network socket even, that's where you look first. I like to use the top command to see what couple of processes are using the most CPU, and that is usually a good first whack at, they might also be using a lot of I/O. They're busy. When I looked at the sumo tests, I saw MySQL up there breaking a big sweat. If you don't find any likely culprits like that, or if you weren't using any external processes at all to do I/O, you can try another command called lsof, which lists all the open files you've got going on. Let's just take a look at that. You pass it the process ID of Python, and it comes back with a list of open files. And you just kind of scan through and see if anything stands out, anything big, anything unexpected, anything that might be hot. In my case, I would have seen a couple of conspicuous lines containing database test fixtures. So a database test fixture, and Will's grinning here, is a special Djangoism. It's hands up if you use Django, so I know how to target. Okay, so a lot of Djangoites in the room. For those of you who aren't, let me give you a quick introduction. Other frameworks have very similar things. Django is a model view controller pattern. Over a quarter of the code is in its model layer, and frankly, Django sometimes feels like an ORM on wheels to me. Like all the code I write always hits the model at some point. All the tests I write pokes a lot of model stuff. So it's unsurprising that Django gives you a lot of library support for setting up fake model data in its test harnesses, and that's what these fixtures are. Here's how it works. The test data goes into JSON files like this one. This is an actual test fixture from the forum application within Sumo. It's not actually a big one. It's 39 objects. It's on a small size, but each of these objects equates to a SQL insert statement. So it tends to add up. Then you take these files and you list their names in your test cases, saying, I want you to use this one, and this one. Here I've added 2 more in addition to the one we just looked at. But when you think about it, loading these 3 files, even if they were twice as big, that shouldn't take any 4 minutes. Where's 4 minutes coming from, right? What's going on? So the trouble became clear when I turned on logging in MySQL. This is a great technique. It's just a matter of logging in as the MySQL root user, and you type set global general log equals on, and then you tail the resulting log file. And what you can see is that fixtures are reloaded separately before each test. Each test begins a transaction, loads the fixtures, runs, and then it rolls back the transaction, leaving your database in a pristine state. It's very tidy, but very inefficient. Load, roll back, load, roll back, load. It's like 3 times and I'm already getting bored with it. Imagine what the computer's doing. On the Sumo tests, this was a total of 37,583 queries. And I thought we should be able to do a lot better. So I thought, why not per class test fixtures? Here's a conceptual mock-up of what I'm talking about. When we set up the class, this is the unit test 2 kind of hook. Not when we set up each test, but when we set up the class, we load the fixtures, and then we commit them. That's the difference. We actually commit these things. Then we run the tests, and we roll back. Now that's exactly what it was doing before, but before it would roll back to an empty database. Now it rolls back to a pristine set of test fixtures. And then, once we're done, we've done 10, 12, 20 tests, we have to forcibly tear it down, because after all, we can't roll back twice. There's no magic where we can roll back to a clean database. We have to say, well, what did we insert? Let's take it back out. And how do we observe that? Well, we run a modified version of Django's stock fixture loading apparatus. And this one keeps track of what was loaded so that we can forcibly undo it. Truncate, 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 truncate. And truncate's a lot faster than delete star if your database supports it. So we use that a lot. With the stock Django fixture loading, Sumo was about 37,000 queries during the course of its suite. With the per class fixtures, only about 4,000. So that's 9 times less traffic to MySQL. Or we can look at it in terms of time, and we can see the stock fixtures taking our problematic 5 minutes, and the per class ones brought us down to 1.5 minutes, which is starting to be at the bounds of tolerability. In fact, it's not represented on this slide, but we saved an additional 4 seconds by reusing the database connection. Django's like, open, close, open, close, open, close all the time. I'm like, why are you doing that? So we stopped doing that, and it took us down to 93 seconds. So about a minute and a half. Big improvement. And all that is thanks to getting rid of I/O. I didn't have to look at individual tests, see what was efficient, what wasn't. Just thought, well, let's just take the first whack. And this is what you see when you profile. Usually the first whack gives you the most return. Then you just kind of keep having and having. But we can still do better. Part 2 of our conquest of speed is fixture bundling. For our second trick, we're going to look at 3 actual test cases from Sumo here. And if you notice, they all use the same set of test fixtures. Now imagine how many times it loads it into the database with our per class stuff. It loads it 3 times, once for each class. Wouldn't it be nice if we only had to do it once? So what we could do is we could merge all this into one big class, right? Take the tests out of class 2 and class 3, stick them in class 1. Great, it'll go really fast that way. But I won't be able to stand it. That kills our maintainability thing. I want to be able to organize my tests as I see fit, not according to what some computer finds convenient. So how do we still get that speed? We take advantage of a really nifty pluggable test runner called Nose. Has anybody used nose in the room? Has anybody used pi.test, which is a cousin? Okay, cool. So you're all familiar with that. Yeah, nose, I love nose so much, I'm going to just pimp it out so much. It helps you eliminate all that crappy boilerplate that unit test likes. Oh, let's make suite, run suite, if name equals main. Oh, come on, I've got things to do. So it discovers your tests. It does profiling and coverage with the flip of a switch. And you can rerun only the failed tests from the last run. And the best part is these hooks. You can write your own nose plugins. And I've really gotten into this. It's so much fun. They give you tremendous power over every phase of running the tests. It lets you find the tests in new ways and choose which ones to run. They tell you can tell it how you want to deal with errors, how you want it to format results. And here's the real dark magic. You can have it muck with tests or the test suite before it runs. I think you see where this is going. So we can do better than per class fixture loading using this last thing. Back to the problem at hand. When Nose runs your test classes, it runs them basically in alphabetical order, like shown here. Now the trouble is, these little colored boxes represent the test fixtures that each test case uses. So first we run test case 1, which uses A, B, and C. Then we unload them. Then we do test case 2, which uses A, B, C, and D. And then we unload that. And then we load A, B, and C again. Now wait a minute, we had already loaded A, B, and C once. Well, let's just, maybe we can have the test runner kind of dynamically reorder the tests like that. And yeah, and then what we can do is set some advisory bits on these things. We can have the reordery nose plugin say to the first test suite, I'm going to set this bit that says, you're the first test in this bundle, in this set of tests that use this unique set of test fixtures. Oh, and you're the last in the bundle. So the first one knows, oh, I'm the first, I better set up the test fixtures. And the last one says, oh, I'm the last, I better tear them down. So throughout all of this, test independence is preserved. We're just factoring out pointlessly repeated setup. In the future, I think you can see one more improvement, which is we've gone to the trouble of setting up A, B, and C. Why should we tear those out just to set up A, B, C, and D? Why don't we just leave them in and add the D? And I'm sure there's some terrible computational complexity in there, but nothing to I/O, right? You can do as many instructions as you want, as long as you don't do I/O. Let's see, yep. So we do a load point there, we do a load point there, we do a load point there. So what impact did fixture bundling have on Sumo? Well, before bundling, we had 114 test classes that had fixtures. So we did the loading and unloading 114 times. However, there were only 11 distinct sets of fixtures. So with the bundling, we only do it 11 times. And that took about another quarter off the time it took to run the tests. Last speed item. Sometimes it's not your tests that are slow, it is the harness itself. So in my case, sometimes I want to run a trivial test. The test takes 1/10 of a second, nanoseconds, whatever. Well, more likely milliseconds. But I have to wait 15 seconds for all the doggone databases to set up at the beginning. I don't care about the databases. I'm not even, instantiating any database stuff. So there's no reason I should have to wait through 15 seconds of database creation, schema initialization, ACL list, population, stuff that was already perfectly valid at the end of the previous test run, right? So we can skip this. We can use what was left over. So building on some work we had already done in this direction, I decided to skip the teardown of the test DB and symmetrically the setup on the future runs. Now that's not very smart, it's not very observant, so if you make a schema change, you have to give it a hint, pass an environment variable, say, hey, you really should reinitialize here. But it's a tremendous net win. I pass the flag on the build farm, I pass the flag maybe before committing, but other than that, I get that nice fast startup. Took it from 15 seconds down to 7, something like that. Still a little crunching in there. So that takes us to within 2 seconds of the mythical 1-minute test run. So here's our overview of our journey so far. There's our stock, there's our per class fixtures, our fixture bundling, our startup speed up. And we're saving something like 4 minutes per test run all told. Now this may not sound like a big number, but it really adds up. At Mozilla we had a team of 4 for a long time, and if we conservatively say that we each run the test suite 4 times a day, which I think is a gross underestimate, wouldn't you say? We save 4 minutes each time, and that's 64 minutes a day. It comes out to 261 hours, or 32 working days a year. And so we can each take a day off every month. So if you do happen to be using Django and you have a lot of fixture-heavy tests and everything, the startup optimizations, the per-class fixture loading, the fixture bundling, everything you see here is available as part of the Django Knows package, which I will be releasing a 1.0 of this weekend, I promise. I'm actually sprinting on it too on Monday if anybody wants to come and hack on it. There's a couple of bugs to fix, a couple of things. There's a caveat where if you're doing any adding more objects from a post-save handler, like if you're doing some logging or something to a table, it doesn't notice that and tear it down. So that's stuff we can fix. There's plans for that. So come and sprint with me on Monday. There's a thing up on the sprints page. Now let us talk about keeping stuff maintainable over time. How do we fix it so that our brains don't get full? We don't have an overflow of complexity as the size of our test suite grows. The database fixtures are a good example of a piece of test setup that gets out of control. But the speed problems are actually the most harmless manifestation of that. There's actually a much more insidious kind of problem here. There's a more general problem, which is that shared setup is really evil. Unit test, JUnit, XUnit, all this stuff that inherits from the Smalltalk original work is kind of encourages you to do the wrong thing. It encourages you to say, def setup, and there's a bunch of setup that all these tests share. Now the trouble is, all these tests usually don't share all that setup. They use bits and pieces of it. Some of it is unnecessary. You still pay the penalty for doing each thing in setup before each test. So you lose a little speed there, but we already fixed the speed part. The real trouble is, it's a coupling problem. Imagine you have this nice setup here, and then your requirements change. Your invariants change, the shape of your objects change, and you have to tweak the setup. Which of your tests have you invalidated? How do you tell? You have to read through each of them. You have to think, put them all through your brain again. It's not scalable. Especially if you're a don't repeat yourself kind of guy like I am, and you've made as many things shared as possible, you're really screwed. You multiply that out. So, what can we do about this? Well, we can break setup into individual helper procedures. This makes it a little more clear, actually a lot more clear, which tests are using what. So we have foo bar quux, and then test foo and bar thing, you can see it explicitly call foo. So we know it uses that part. And it's a little bit longer to type, but it's equally efficient because setup runs every time anyway. In fact, it's more efficient because we don't always have to set up things that we don't use. You only pay for what you eat. You can improve the spelling too. You could use memoized properties. You can do all kinds of tricks. But this is a good direction to go for keeping things maintainable, I find. Now, the equivalent thing happened to us with Django test fixtures. On one occasion, we had this test which makes sure that a user in a specific group can't change the locked status on a forum that he doesn't have permission on. Well, it's a good thing we have the doc string because I have no idea what fetching user of ID 47963 means. I mean, what group is he in? Does she have a permission? I don't know, it's not obvious. You have to look aside into some other file, which you have to fit on your screen. You scroll around, and you've got to do joins in your head between this database ID and some permissions row someplace. It's just not optimal. I want all the useful information here and none of the irrelevant information here. So what can we do about this? We can use things called model makers. And this is a pattern, not a library. These are really, really simple to write. It's more of just kind of a best practice that's emerged. The thing on the third line, document, that's a model maker. What it does is instantiate an ORM object in memory, says, oh, let's make a document. But what it does is it fills out just enough of it that it would be a valid object, that you could save it. It meets all the invariants. In addition, anything you pass into it, it'll set. So here I say, I want a document with title equals test. I don't care about the rest. Do whatever you have to do, set the timestamps, fill the non-nullable columns to make the database happy, but just make sure it's named test. And by doing this, it's very, very clear what your test is assuming. All your assumptions are right here. I want the document with title equals test. Assume nothing that you don't state. Even if the document model maker defaults to setting some flag to false, don't assume it's false. Set it explicitly. And then your tests are kind of self-documenting. You can nest these things if you make them right. So this is a test for Sumo's wiki, which is made out of wiki documents or wiki pages, and then they each have a bunch of revisions, kind of like Wikipedia. And here I'm saying, make a wiki document revision, And if I didn't say document equals whatever, it would just come up with a document to attach it to, because a revision has to have a document. But since I said document equals whatever, it's saying, okay, well, you want a revision, and not only that, you want the document to be having this title. And then I say a few other attributes that I think are important for this revision. There are no database hits here. It's lexically very clear. It sort of reflects lexically the structure of these objects, even if it is a little inside out. And there's no library to write. There's no learning cost to pay. You just read a couple of these things. Here's the implementation. It's like 6 lines, and this is one of the more complicated ones. I got fancy, and I called the type, put into the title a Unicode character to just expose all the Unicode errors we have, and added a timestamp on. But there's nothing to it. And then the one little library-ish thing I did is I made a with save decorator. And all that does is when you're saying document title equals this equals that, you can say save equals true at the end, and it'll actually save it in the database. That means you can do one-liners like I did before without having to instantiate separately and then say, all right, next line, document.save. Makes it a lot clearer to lay out. Now, some people have actually written libraries for this. There is a Django-centric one called FactoryBoy, which lets you do this in a more declarative way. I'm kind of up in the air about whether the extra complexity is worth it or not. It kind of looks at your models and tries to figure out what a valid model would look like. And sometimes it guesses wrong, and you have to figure it out. This is based on a Ruby thing called Factory Girl, which is a Rails thing. So I say, in summary, that every shared setup routine is irrevocably corrupt. It couples your tests together needlessly, it makes them brittle, it makes them hard to understand what bits they depend on and which things are don't cares. And furthermore, the setup is lexically very far from the test code, and everything ends up slow. So, wouldn't it be preferable, all things being equal, to make it modular and put everything lexically near each other? Then you've got nice decoupling, you've got robustness, you've got clarity, it's easy to grok. You've got efficiency, you only have to pay for the setup you eat, and you've got puppy kisses, which everyone loves, unless you're allergic. Plus, you've got the freedom to factor things without breaking tests. You can move your tests all around because they're not like bound to some setup thing. You can reorganize them. You can put your slow tests in this class, your fast tests in this class, and run the fast ones every 10 seconds, and you can do whatever you want. It gives you tremendous freedom. Now, of course, there are some situations where you don't want to set up these full model objects or other sorts of heavyweight objects at all. And that's where mocking comes in. A mock is something you use when the real thing is too performance intensive or too complicated to understand clearly. A mock is a self-evidently correct lightweight substitute for a more complicated thing. So we use the mocks to test the code that operates on those things. Take the typical HTTP request object. This is a Django one. They're all the same. It's kind of complex. It's a couple pages long. It's got a lot of ifs, a lot of branches in there. And this is a mock HTTP request. Self-evident what it does. All it does is what we need. We don't pay for what we don't need. We don't have to make up arguments to instantiate it. We don't have to make up an HTTP method name or something just to make one. For this sort of thing, you don't need any libraries or any help. Now, if you want more elaborate mocks, like ones that keep track of what was called on it, or maybe sends a fake return value that changes over time, first return 3 when I call this, then return 4 when I call it again, then you can start to need a library. My rule of thumb is like when I start to need tests for my tests, then maybe I should use somebody else's library they've already tested. And there are 2 that I really like. There's mock and there's fudge. Mock is very imperative and fudge is more declarative. And sometimes one feels more natural and sometimes the other one does. So I'll show you both because I use both. So let us see mock. Take a look at this with block, which calls patch.object. What this does is it takes the object API voter manager, it's just kind of big business object, and says, well, there's a method on that called raw voters, and I want to replace it. I want to replace it with something that just is a mock and does something very simple and predictable. So it binds this new mocked out object that replaces raw voters to this value of voters. And then I can say, hey, your return value is such and such. Cool. Then I can do my test, make one assert, and then I can make a second assert that this method was called. So I did the return value, and it kept track of whether it was called for me. It's very fast. It doesn't have to run through all the logic of raw voters, which is a couple hundred lines of heuristics. It doesn't have to hit the database. Prevents the brittleness of depending on test data. It gets the sleeps out of your code. Like if you have a test harness that's all starting up and shutting down search engines and populating them with stuff, you don't have to deal with all that. It's just a huge win all around. And then fudge is the more declarative path. It's just a difference in spelling, but I find this one preferable when you're writing things like facades. This piece of code tests Oedipus, which is a library we put together to put in front of the Sphinx search engine, which has kind of a Java-esque API natively. We thought, well, I wish this looked more like the Django ORM, where you could chain methods and things like that. So you can see what we're trying to get to down at the bottom, this sbiscuit filter. That's what we want to work. Now, since this is a facade, all it really does is make API calls through to the Sphinx native API. So what this red thing is that fudge does, it says, here are the APIs, the API calls I expect my thing to be making to Sphinx. First of all, I expect it to be called, expects call. I expect it to call setFilter with these arguments. I expect it to call setFilter again with these arguments. I expect it to call setFilterRange with these args, setFilterRange with these args. And finally, I expect it to call run queries for which you should return no results. Now, what you don't see is the assertions. The assertions are hidden from you, and those are taken care of by the fudge decorator up at the top. After this procedure exits, it pops up into the wrapper, and the wrapper does all your asserts for you. And it'll print out nice messages, much nicer than you'd bother for a one-off, so you get that advantage too. Let's see here. Let's talk about how to make your tests more informative. Starting to run out of time. There's so much you can talk about with testing. I mean, you can go on literally all day. I guess I have a whole track full of testing, so it's been pretty impressive. How do you make your tests more useful to humans as they're running, after they're running? How do you make them do as much of the computery work for you so that you can do, as a friend of mine says, the talking monkey work? How do they help you diagnose? How do they help you debug? I hate dots. I hate them. I can't get off stage without complaining about the dots. This is a standard Django text display. It's a standard everything test display. It's what text test runner, say that 5 times fast, does in the standard lib. It's just dots and dots and dots forever. And as you see, there's an E there. So, oh, I had an error. That's great. What's the error? You know, can I start chasing that? No, I have to wait for more dots. Okay, fantastic. Yeah, I didn't have anything to do. Should I get a drink? I can't even see how far along I am. Should I get a drink? Should I get a sandwich? Should I get married? I mean, this test suite goes on for over 2 minutes. So now's a good time to start thinking about the questions that you want to ask. We'll just wait. Finally, let's see. I will skip ahead here. At the very end, we are finally left with a messy bunch of tracebacks. Tracebacks are terrible. I hate standard Python tracebacks. You have to kind of churn through this forest of noise. There's all this file, and then before each one there's like all these lines of equal signs that the test runner spits out, and there's traceback, most recent line last, as if you've never seen a traceback in your life. You know, terminal windows are small, right? So we need to make better use of our space, and we need more prompt error reporting so we can start chasing this junk as the test suite runs. So wouldn't it be nice if we had something like this instead? I put together an alternative test runner called Nose Progressive. Works with your existing tests, just like Nose does, without you having to change anything. And it shows you a progress bar down in your lower right. You can see how far along you are, whether you should get a sandwich, whether you should start dating. You've got a name of the test on the left, so you can see that this test is really slow. It's taking forever. Come on, come on. And then it reports the tracebacks as you go. Now, the tracebacks are a little unusual, as you can see. For one thing, they're more compact. I use relative paths where I can. I strip out all the cruft. All the procedure names are colored, so you can go right down, go from function to function to function, see exactly where you are in the stack. It omits all the test harness stack frames. It omits, in fact, then as soon as Nose updates, it's going to omit those assert equals test frames a little better. There are no wasted lines, no wasted columns. And the best part of all is these editor shortcuts. Each line in the traceback, each frame starts with bbedit. Here you can see because I use a lot of bbedit, but it'll work with your editor too. You can copy and paste these lines. You can just triple click, copy, give it a paste, hit return, and up you pop into your editor at the line of the error. So you don't have to like scan through there and like line 1467, 1450. Oh, I got the wrong line. You don't have to waste time. This is computer work, not talking monkey work. Works with all the editors. Works with VI, Emacs, TextMate, bbedit, anything that obeys that little plus syntax for line numbers. And you can have it right now. It's up on PyPy. It's reasonably mature. I'm going to be sprinting on this on Monday too, if anybody cares to join me. All you do is pip install nose progressive and then run nose tests -- with progressive. So I want to thank everybody I ripped off images from today. I love Flickr and searching by Creative Commons license. It's fantastic. Are there any burning questions? In the back.
When you, I was just wondering about zope.testing and zope.testrunner. Zope.testing provides a layered concept where you define shared test fixture in a totally separate from the test classes, and then you can assign multiple layers to the test case, and it does the dependency resolution for those layers for you. That's been around since I think at least 2006.
Exactly. So he brought up Zope's.
Also does the progressive output and has good handling of remote command line flags, so that you can, have it'll output the test that's running, it'll show progress, it'll show tricks as they're happening.
Right. So he is pimping the Zope test runner, which does many of the things I described. And actually, I come from the Zope world. I wrote a book on Plone called Plone 3 for Education. And yeah, that's what I missed when I got into Django. It's like, where's my percentages? How far along? Where's my stuff, man? And so, what's nice about this nose plugin is that you can kind of port this from project to project without having to eat the whole elephant that's the nose test runner. But the nose test runner is fantastic. And it does things like you can define dependencies and then kind of tag them onto things. Say, I use this test layer, I use this test layer, and the runner will kind of figure out how to hook all that together like the fixture bundling. Yeah, it's always good to look at what Zope is doing because Zope is 10 years ahead of everything and has made most of the mistakes. It's also accumulated 10 years of cruft and layers, so that's the downside. Yeah, so that's pretty decoupled. The Zope testing package is decoupled. The zope.testing package is pretty decoupled and usable with other things.
Yeah, I use it for my pure Python packages that have nothing to do with the stats, and it might pull down zope.interface.
Great, so that's another thing to test out is the zope.testing package. It's reusable with normal Python stuff. Don't be afraid if it says Zope in the front. It won't bite you. Yes?
Along the same lines, twisteddotchild works with every single unit test implementer except Django because Django is broken. You can sprint to fix Django so that it works with trial.
Excellent. So there is one called twisteddotchild that's also a general purpose test runner. It works with everything but Django, and it's Django's fault, it is alleged.
It totally is.
It totally is, I'm told.
So this is just sort of a suggestion for my personal life. When tests get slow, and Buildbot's test suite is not particularly slow, it's 20 seconds, but I have keyboard shortcuts in Vim that help me figure out like what file am I editing, what minimal set of tests run for that. So when I'm doing TDD kind of things, I'm running just the unit tests for that file. So in terms of figuring out sort of how to make developers faster, saying you don't have to run the whole suite every time is a good way to make the cycle quicker.
Yeah, so this is suggested that if you structure your code properly so that all of your code in this module is tested by the tests in this module, which is hard to do sometimes if you don't have big black walls between stuff, you can get pretty good assurance that you're getting good test coverage just by writing some cool macros for VI or whatever, noticing what file you're in, running the tests. I've even seen people write runners that run tests continually in the background based on what you're changing. David Kramer was even trying to do something like this with nose. There's a package called Nosebleed that was supposed to take a look at your coverage graphs and figure out what stuff needs to be run to test the lines of code you changed, and he gave up. But so we'll try again at some point. Yes?
Have you had any experience running your tests in parallel?
Great question. So the question was, have we run the tests in parallel at all? And that is a future thing. The state of the parallelization support in py.test and nose is kind of right now. The nose one could use some work. The PyTest one's actually better right now. It's a PyTest advantage. That's the next step. Yeah, once you're CPU bound, which we're at about 75% CPU after all this stuff, that's the next thing to do. Yeah, definitely. Twisted Trial does that well. Yes?
Do you have any recommendations for integration testing as opposed to just unit testing?
Absolutely. If I have a limited amount of number of dollars to spend on testing, which I always do, I go straight for integration testing because that gives me the coverage, right? It's going to break if any of this junk breaks. Now, the trouble with that is obviously it doesn't really tell you where it breaks. Sometimes you got to kind of snake back through and say, well, what actually went wrong? Unit tests give you much faster developer feedback. Well, this line right here is the problem, and they run faster. But I kind of do them as a second whack unless I'm writing a very simple package. A mixture of both is what I usually end up with.
This is a loaded question, but my question is, which database engine are you using on the back end for Django for your test runner?
I'm extremely sorry to say I'm using MySQL on the back end to run my tests. We're using that because we run it in production, and you want to make MySQL's broken enough to not test. Now, I've voted and we want to switch over to Postgres because MySQL is just horrendous in every possible way. As I like to say, if it has an opportunity to suck at something, it takes it with gusto.
So as far as I know, on Django 1.2 at least, it doesn't support transactions.
What?
For the MyISIM engine. So loading the fixtures takes up for InnoDB, it has problems right now. And so I don't know if you encountered that issue and whether or not you did commits and rollbacks.
So are you saying that it maybe does a separate transaction for each little piece of the text fixture that it loads in?
I'm talking about that you can't roll back and roll forward using InnoDB. That's interesting.
We do that all the time.
Okay, so because I think it has some problems with fixtures dealing with foreign constraints that's being fixed in Django.
Circularities are a problem in fixtures, and maybe in our custom stuff that we say, stop obeying foreign keys and then do this junk because MySQL takes an opportunity to suck at circular relationships within transactions. Yeah. Any further questions? I think we're right on time. I think this is a good place to end it. I want to invite everybody to come to my testing sprint on Monday. It's on the sprints page. I'll fill in location stuff as we figure it out. We're going to be working on Django nose, squashing some bugs. We're going to be working on doing a release. We're going to 1.0 out. We're going to do it. We're going to work on nose progressive, maybe squash a few bugs there. And everybody's welcome. Thank you very much.